Okay, this is the addendum to the September 2021 trial exam. If you were lucky enough, this addendum will have been issued to you when you started writing your chemistry trial exam. If you were not lucky, there was a fertilizer question that you got panicked by and thought you had to answer. So if you had this question, or if you're just studying, this is the replacement question, because fertilizers disappeared out the curriculum from November 2020 to September 2021. It says the electrolytic cell illustrated below is used to electroplate a nickel rod with copper. So what are we doing? We are putting a copper coating onto a nickel rod. Okay, so you have one metal, it's cheap like this, and you come and you build another metal that's more expensive or prettier or whatever on top of it. So we have the nickel core. Okay, a nickel core like this, and we put the copper on top. So which one of the following is the correct representation of a suitable electrolyte and the nickel rod that should be used in the above cell to obtain the expected results? So if you want to copper plate something, you must have copper 2+ ions in solution that are then reduced to copper metal by the gain of 2 electrons. So this is the reaction that you want to occur on top of the nickel electrode. So we need a solution that contains copper ions, okay? And also, to keep the copper ions in solution, one of the electrodes is copper that gets eaten away by forming copper 2+ ions into the solution, and then these two are connected by the external circuit, okay? So this gets worn away. So one electrode gets worn away and the other electrode gets built up, and you have the copper 2 ions in solution because that's what you want to build up. You want to build up the copper. So it's got to be B or D. Then the next point is, which of these two electrodes is in actual fact the nickel? So if you have a look here, if we look, there is a battery in here. Because this reaction doesn't want to occur, you have to add energy in the forms of electrical energy from a direct current source. So here's my direct current source, and this side is positive and this side is negative. So what do we have going on here? We have a flow of electrons in this direction out the negative terminal. So that makes this terminal negative and this terminal positive, okay? So where will my cations, my Cu2+ ions, go? They are going to go to this end here, Cu2+, because opposite charges attract. They are attracted to this negative one, which is full of electrons, and there they will be transformed from Cu2+ to Cu metal. So we need the nickel rod to be Y. So the answer to this question is in fact D, because we have copper 2+ ions in solution, and then we have the correct electrode. Now, consider the table of standard reduction potentials below. Okay, so this looks pretty standard. It looks like your table. It looks like table B, or part of table B, because remember, table B starts with a negative number on the top and ends with a positive number on the bottom. Table A is the other way up. Okay, so let's have a look here. They are checking to see, do you actually understand that table? It says define the term reducing agent. Now, a reducing agent is in actual fact a substance that is oxidized, okay? So it is something that is oxidized. And remember what I always tell you to remember when we do this, we have to remember oil, rig, red, cat. Oxidation is loss. Reduction is gain of electrons. So if you are oxidized, a reducing agent is oxidized and it undergoes the loss of electrons. Okay, so it's a substance that is oxidized, or a substance that loses electrons. So we shouldn't write loss of electrons, we should say loses electrons. Okay, now it says write down the name or the formula of the strongest reducing agent. Now this is called the table of standard reduction potentials. So this means that the forward reaction is reduction and the backward reaction is oxidation. Okay, so in this thing here, they want the strongest reducing agent, which is in fact oxidized. So we want something that likes being oxidized. So chlorine gas at the bottom here on the one extreme has got a very positive value to go to a chloride ion. This forward reduction reaction wants to occur. And if we look here at the Cr2 plus 2 electrons goes to chromium, this reduction reaction does not want to occur. It has a very negative value. But we want to look for something that is oxidized, which is the reverse reaction. So this forward reaction is very positive. It is likely to happen, okay, easily, or it happens easily. This one, the forward reaction, is not likely. And if the forward reaction is not likely, it means the backward reaction is very likely. So the strongest reducing agent is something that is in fact oxidized. And what will be oxidized most easily, because it is got the lowest reduction value, is the chromium metal. You can't say chromium 2 plus, okay, because that undergoes a reduction reaction. We need something that undergoes an oxidation reaction because a reducing agent is oxidized. So we have to pick the chromium. It is the most likely thing to undergo oxidation. Now it says the reduction potential of the half reaction in which Cr2 plus aqueous acts as a reducing agent. Here we've got Cr2 plus aqueous acting as a reducing agent. So if it is a reducing agent, it has to be on the right hand side, okay? So have a look here. There are in fact two reactions here that have a chromium 2 plus in them, okay? Can you see here, is there more than one with chromium 2 plus? Here's a chromium 3 plus, chromium 3 plus. Just check everything very carefully, but basically it's these two reactions that have got the chromium 2 plus. But we want the half reaction in which chromium 2 plus is the reducing agent, which means it's oxidized. So we are looking at this value over here. So it is an E theta of minus 0.41. Don't forget your unit of volts, which is on the top of the table. Okay, now it says to you, a learner pours copper 2 sulfate into a zinc container. Is a zinc container suitable to store a copper sulfate solution? Choose from yes or no. Well, the short answer here is no. If you have ever put a piece of zinc into a copper sulfate solution, you will notice that the copper sulfate solution goes from being blue to colorless, and the zinc basically goes from being a shiny silver metal to disappearing, and you get this black and reddish brown thing precipitating out in the container, which is basically the zinc. If you put zinc with copper sulfate, the zinc goes to zinc 2 plus ions plus 2 electrons, and it forces the copper 2 plus ions. They accept the 2 electrons and form copper metal. So if you do this, your zinc container will disappear, and you will have a little puddle of little powdery copper. So then it says, explain the answer to question 10.3.1. By the way, we call this a displacement reaction. Yes, this is a displacement reaction. Explain the answer to question 10.3.1 by referring to the above table. So if we look at the above table, we will then, we're wanting to look at which particular reactions. Here is Zn2 plus 2 electrons, and here is Cu2 plus 2 electrons, okay? So if we look at this table, we will see that on this side of the table, these are, what did we find on this side of the table? We found on this side the reducing agents, and because they are oxidized, and on this side the oxidizing agents. So what is the short answer here? Zinc, the metal, not zinc, the iron. Zinc is a stronger reducing agent than copper, okay, and the zinc will be oxidized to Zn2+. The copper will be reduced to Cu2+. So copper gets reduced to copper ions, zinc is oxidized to zinc ions. So you can either say zinc, the metal, is a stronger reducing agent than copper, or you can say copper is a weaker reducing agent than zinc, and the zinc gets oxidized. But you must make sure that when you state this, you make sure that zinc, the metal, not the iron, is the stronger reducing agent than copper, the metal, and the zinc is oxidized to the zinc ion. Be careful, an ion and an element are not the same thing. But that is the answer to the errata.